expansions. And at first you might say, how does this relate to what we've been learning? But you're going to soon find out. It's kind of cool. There's some cool stuff going to happen today. You're going to see some cool patterns, and I hope you enjoy it. So the first thing we're going to talk about, we're going to talk about this thing called the Pascals triangle. There was a French mathematician, Pascal, and he kind of determined and found this really cool triangle that if you look at it, it's kind of interesting. If you ever played or ever watched The Price is Right when they play Plinko, you'll notice that they drop a chip down and it hits a peg. So the first peg that it hits, there's only one way for it to get there, and that's for it to drop down and hit that peg. Now from that peg, it has a choice. It can go to the left or it could go to the right. So to get to this position right here, there's only one way that could happen. It'd hit the peg and go to the left. To get to this position, it'd have to hit the peg and go to the right, so there's still only one way to get there. To get to this position right here in the middle, though, it could have hit this peg, gone to the left, and come back to the right. That would have made it there. Or it could hit the peg, gone to the right, and come back from the left. So there's actually two paths that it could have followed to get there, and that's why that number is 2 there. Now, if you look at this one right here, it would only one way because it'd have to stay to the left. To get to this one here, you'd have to stay to the right. To get to the 3, well, I know there's 2 ways to get to here. So from here to there, there's 2 ways. Then I could have gone left, left, and come back in, so one more way makes 3. So again, from here to here, there's 2 ways to get here. I could have gone to the right and come back in 1. That would be one more way. So this is a 3 here. This is a really cool pattern that really develops pretty quickly. Now, if you look at it, we have 3 ways here, right? So 3 ways to here, but then it could have stayed left and then come back one way. That would have been a 4. Notice what number's right there, 4. How many ways can it get to here? Well, it'd have to stay to the right, 1. Okay, so what's going to be right here? If you look at the pattern, it's going to be a 1. In fact, all these, all the way down, are going to be 1s. So this is pattern number 1 that you're seeing. How do we get to this number? Well, we just took 4 and 1, added them together, that gave us the 5. You might say, how do you get the 6 here, Ruck? Well, from this one, I could have come over, which would have been 3. And from here, I could have come over, which is 3. So 3 plus 3 is, that's right, 6. How do I get the 4? Well, 3 plus 1 is 4. How do I get 5? 1 plus 4 is 5. How do I get 10? Well, 4 plus 6 is 10. How do I get 10 again? 6 plus 4 is 10. How do I get this number? 4 plus 1 is 5, or it's the same as that one, because it is kind of a symmetrical deal here. How do I get to this number? Well, 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Oh my gosh, it's so cool! This one's going to be 7, 21, 35, 35, 21, 7, 1. 1 and 7 make 8. 7 and 21 make 28. 21 and 35 make 56. 35 and 35 make 70. 35, 21 make 56. 21, 7 make 28. 7 and 1 make 8. Oh my gosh. Up, down, it goes the same. Cool. 1 and 8 make 9. 8 plus 8, 28 is 36. 28 plus 56, 84. Be careful. 56, 70. 126, 126. Now we know it just repeats. 84, 36, 9, 1. Because once I got to that repeating part, I knew I just followed the symmetry. 1 and 9 is 10. 9 and 36, 45. 36 and 84, 120. 120, 126. Be 246. 126, 126. Make 252, right? Maybe, yeah. This should not have been 246. I lie. Lie like a rug. Rug to quit lying. 6 plus 4 is 0. Bring up the 1. 10, plus 1 is 1, 210. That's 210, 252. These two are going to make 210 again. Okay, so there it is. 120, 45, 10, and 1, and there's Pascal's triangle. You can keep going as long as you want to go. All right? Now you might say, what the halo does Pascal's triangle have to do with anything we've been learning? Well, I'm going to show you here something. This is going to be kind of cool. We're going to look at these. 8C0. I'm going to do them on my calculator, okay? So, 8, math, PRB, down to number 3. Choose 0. Get out 1. 8, choose 1. So I can actually now go second, enter. And I'm just going to change that to a 1. So I'm just going to change those 8. 8s are going to stay the same and change to 1. That's an 8. Again, I did that by hitting second, enter. Going back, change that now to a 2. And I get out 28. You're trying to see what, like I told you, I'm going to show you how these kind of relate. So you're trying to see, hopefully you can, and hope you're trying to see maybe how this relates to something up here. 8, choose 3. So again, hit second, enter. Go back and change the 2 to a 3. And it is 56. Oops. If you see it, do you know what 8C4 is going to be? I do. I know what it's going to be right now. Without even doing it. It's going to be 70. Let's take a look. Oh, ho, ho! It's 70. How about 8C5, huh? Second, enter, go back, change it to a 5. Do you know before I push the button what it's going to be? It's going to be 56. I don't know, let's see. Answer is 56. I bet then it's going to be 28, then 8, then 1. Let's check it out. Change it from a 5 to a 6. Should be 28. Change it from a 6 to a 7. Should be 8. Change it from a 7 to an 8. Is 1. Ha ha! Well, how did I know that? Do you guys see these anywhere up here? I don't know, maybe like... Yeah, that's kind of cool. Okay. By the way, I don't know if you know this or not. This is considered row 0. This is considered row 1. This is considered row 2, row 3, row 4, row 5, row 6, row 7, row 8. This, of course, would be row 9, and, of course, then row 10. You can always tell which one it's on because that second number in kind of gives it away. So, so each of these rows could be done by just using a combination. And notice that we started with 0, 1, 2, 3, because this was the 0, this is the 1, this is the 2, this is the 3, 4, 5, 6, 7, 8, 9, 10, because 0 being the first, the initial. That's why we use 0 there. Okay? Interesting. Interesting. Okay. So now the question is maybe how does this relate? So you can now see the relation to Pascal's triangle and combinations. Now how does it relate to a binomial expansion? And what exactly is a binomial expansion? Well, a binomial expansion is where you're going to take a binomial, which is something with two terms, and you're going to like square it, take it to the third power, fourth power, fifth power, whatever, and you're going to expand it out. So let's just do a couple, and I'll show, and you'll see it. You'll kind of see, and you're going to see some things come out, okay? So let's try this one. Let's try this one first. Let's take x and plus y. We're just going to take x plus y. We're going to take it to the 0th power. Well, you all know anything to the 0 power is what? That's right, it's 1. So, okay, that equals 1. That's interesting. Isn't it? Yeah, that's interesting. Okay, so let's try. Maybe I should write this out a little bit. You know what? I'm sorry, guys. I'm going to just erase this just for a second. I'm going to write a little bit more here to the left. I have a little bit more room, so I'm just going to write over here a little more left. So hopefully you're okay with that, okay? So we have x plus 0, or sorry, x plus y, the 0 power, and we said that is 1. Okay, let's do x plus y. That's not an x, right? Come on, Bubba. Pay attention here. X plus y to the 1. Well, I think you all know what x plus y to the 1 is. It's 1x plus 1y. Okay. What if we did x plus y squared? Now be careful. Be careful. Remember, I always tell you to multiply it, write it out, right? So I'm going to just write it out right up here. X plus y times x plus y. Distribute out. X times x is x squared. It's going to be an xy and a yx, which is another xy, really, and a y squared. So in other words, that gives us 1x squared, 2xy, and 1y squared. Huh. That's interesting. Let's look at x plus y cubed. Remember, we're trying to find some relationship between this and what's happening over here. So x plus y cubed would just be another x plus y times that. So in other words, I'm going to take x squared plus 2xy plus y squared, and I'm going to multiply it by an xy. So that's going to give me an x cubed, a 2x squared y, and an xy squared, and then an x squared y, a 2xy squared, and a y cubed. So in other words, I get x cubed, 2x squared y plus 1x squared y is 3x squared y. 1xy squared plus 2x squared xy squared is a 3xy squared, and then a 1y cubed. Do you guys see it yet? Do you see it? That's what I'm wondering. Do you see what I see? Do you see what I see? A pattern going right along with Pascal's triangle. So if I wanted you to do x plus y to the 4th, if I wanted you to do x plus y to the 4th, would you know what numbers go right here? Hopefully you do. They're right here. 1, 4, 6, 4, 1. Now the only thing I got to figure out is how do the variables go? Well, let's take a look. That was x to the 1, y to the 1, x squared, x to the 1, no x, no y, y to the 1, y to the 2, interesting. X to the 3rd, x squared, x to the 1, no x, no y, y to the 1, y squared, y to the 3rd. X to the 4th, x to the 3rd, x squared, x to the 1, no x, no y, y to the 1, y to the 2, y to the 3rd, y to the 4th. We can use Pascal's triangle to help us expand a binomial expansion. Let's see how this thing works. Now, I'm gonna be done for right now, and I'm gonna show you. I'm gonna do another video that's gonna expand some of these out. Actually, let's just do these really quickly down here. We just did them actually, if you remember correctly. We just did. This was 1, x plus 1. That's gonna be 1x plus 1y. The 2 was the 1x squared, the 2xy, and the 1y squared. Xy cubed, we said was the 1x cubed, 2x squared, y, notice that, plus, not 2, wouldn't have been 2, hello, for class to get. That'd have been a 3. This would have been a 3. XY squared and 1y cubed. Okay. Notice what's going on here. Xy to the fourth would be 1. X to the fourth, 4. X cubed y, 6. X squared y squared, 4xy cubed, and 1y to the fourth. All right, I'm going to stop the video now, and we're going to go ahead and we'll do the next page on my next video. Have a good one. Bye.